In the previous video, I gave some list-like data structures in Python and said some of the differences between them. But to really appreciate how fundamentally different they are, you should really see how long different operations take. So let me focus on just 3 of these. Let's import numpy as np. And let me make this variable called myArray. And I'm eventually going to be taking reciprocals, so let me start at 1 instead of starting at 0, and let me go up to 10 million, 10 to the 7th, and the step size will be the default, which is 1. Okay, and if I check what's the type of my array, I get that it's a numpy.nd array. And let's also make a list version of this and a set version of this. So let's say my list equals, convert it into a list. So list of my array. Okay. And let's say my set equals the set version, my array. And we can do similar things with all 3 of these. For example, I can ask, is -2 in my array? And pay attention to how long these take. I can ask, is -2 in my list? And I'm getting false as the output because it's not in any of these structures. And I can say is -2 in my set. And they all seem to take about the same amount of time, but really there's a huge difference. It's so fast that we can't detect it at this size. But let me precede this cell, so this has to be the very first line in the cell, and let me put timeit. And what this is going to do is it's going to tell DeepNote to run this cell a bunch of times, time how long each of these executions takes, and then report the average. So let me time how long it takes to check, is -2 in my array? And while we're waiting for that, I'll just start typing the next one. I'm going to say timeit, and then -2 in my list. So this one took 7.48 ms, and ms stands for milliseconds. So this is like about 7,000ths of a second. So it's around like 1/100th of a second. Okay, whereas how long did this one take? So you can see that it's like hugely more time. This took over 1 second. Okay, in this case, it did this 7 times with 100 repetitions. So it did this 700 times up here, whereas in this instance, it just did 7 repetitions, not 700. So there's a huge difference between these. Let's try another one. Timeit -2 in my set. And let's see how long this one takes. So NS stands for nanoseconds, so 10 to the -9th seconds, so like 1/1000th of a second. So this is even much, much faster than the myArray version, which was much faster than the mylist version. And I'd say this is like one of the fundamental properties of sets, is that you can search to see if an element is in a set extremely quickly. So that shows one clear advantage of set over list. Let's see what one big advantage is of myArray. So NumPy, it's really well suited for doing algebraic manipulations or linear algebra manipulations. So for example, if I want to let me just show you what happens if I do 1 divided by myArray. And then let's just look at the first 10. So this is like element-wise reciprocals. So it's 1/1, followed by 1/2, followed by 1/3, etc. Okay, and let's see how long this takes. And let's start with the list version first, because I want the most impressive one to be at the end. And I'm not even going to do it for set, because taking a reciprocal of everything in a set, I don't think that's such a natural operation. So for example, let's say, how about new list? Okay, that'll start with an empty list. And then we'll say for x in my list, new list dot append 1/x. And let's time this. So one nice thing about this timeit function is that it can work even when the cell has multiple lines or like multiple steps in it. So let's see how long this one takes. So this is trying to create the same thing as just doing 1 divided by my array will make. Okay, so it didn't take that much longer than this seemingly easier thing of checking is -2 inside of the list. It took about a little under 2 seconds. And so what I hope you think when you see me doing this is, oh, well, he forgot to use list comprehension. That'll make it faster. And really, list comprehension makes things more elegant and more Pythonic, but list comprehension doesn't make things faster. So might make it a tiny bit faster, but that's not what you should imagine is the benefit of list comprehension. Instead, you should imagine the benefit is that it's more readable. So like the list comprehension way of doing this, still with a list, is 1 over x for x in my list. And let's see how long this takes. And what I'm expecting is that it's going to be very similar to this 1.77 seconds. So it's a little faster, maybe about 20% faster, but essentially the same, definitely the same order of magnitude. Now let's see the array version. So with timeit, and then we can just do 1 over my array. And let's see how long this takes. And the secret reason this is much faster is because NumPy uses what are called vectorized operations. So it has a way of having the computer execute this like all at once rather than for one element at a time. And so this took 31 milliseconds. So this is about like maybe 50 or so. Let's see, if I multiply it by 5, then I get 155 milliseconds. So it's about exactly 50 times faster using this array version versus this list version. So you should imagine that for loop versus list comprehension, those are approximately the same. And you should imagine that this vectorized version using NumPy, that's much faster. And if you had an even longer list, like one with length 100 million instead of 10 million, then you'd see an even more noticeable difference in the times that these operations take.